Once again guys, we are here and come up with a new part, that is elements of the earth magnetic field. You must have seen in the previous parts that earth is surrounded by a magnetic field. Now let's say you are at any place on the earth. How do you get to know that what is the magnetic field over there? So for that we have certain elements which defines at a particular position on the earth that what is the magnetic field. So for that detailed discussion, let's proceed. Now guys, elements of earth magnetism. So the earth magnetic field at a point on its surface is usually characterized by three quantities. First is the declination, we represent it by theta, and after that we have the inclination or the dip, we represented it by delta, and after that we have the horizontal component of field that we represent it by BH. So we have seen that horizontal component we have seen in the previous part also. So the third component is horizontal component of the field. Now let's proceed. So let's talk about the declination first. Now declination means it is represented by theta. So in the previous part we have seen that this is the geographic meridian, that means the plane passing through the geographic poles, and after that we have seen the magnetic meridian, that means the plane passing through the magnetic poles, that is magnetic north and magnetic south. This is called the magnetic meridian. So these are the two planes, and if we say that the angle between the two is theta, that theta is the declination. And so why we are specifying this theta? Because theta declination or the angle between these two planes are different at different places. So this is the, if we say that the magnetic field, obviously the resultant of the magnetic field is there in the magnetic meridian. So if we talk about that magnetic meridian, resultant magnetic field is B, then if this makes an angle with the horizontal line, that we call it as BH, that is the horizontal component. If the resultant making an angle delta with BH and this is BV, so therefore we have, and we'll talk about this thing later on. Okay, the angle between, now let's talk about only the declination. So the angle between the magnetic meridian and the geographic meridian at any place is declination at that place. It varies from place to place, we have talked about this thing. And the line shown on the map through the place that have same declination means if you look at the map, if we have seen that there are different there are different places which have the same declination, we call that line as the isoconic lines. And the line drawn through the place which have zero declination, we call it as the agonic line. So otherwise we only have to remember this thing, that theta is the angle between the two meridians. Now let's proceed towards the dip. Now dip or the inclination, so the angle between the horizontal component of the earth magnetic field and the earth resultant magnetic field at a place is called the declination at that place. So we have seen in the diagram that this is the angle delta. So I have already told you that this is the angle delta, and this angle delta is the angle between the horizontal component BH and the resultant magnetic field in the magnetic meridian only. So it is zero at the equator, and 90 at the poles. So we'll check it out that how it is coming out to be 0 and 90 degree at the poles diagrammatically also in this part only. So lines drawn up on a map through a place that have same dip is called isoclinic line, and the line drawn through the place which has zero dip is known as eclinic line, and it is the magnetic equator. Now we'll check it out all these things in the 0 and 90 degree at the diagrammatically only. So if we look at the map, so this will be isoclinic and eclinic line are available over there. Okay, so this is the diagram. This diagram shows that if we place at different places, if we place a magnetic needle, so magnetic needle will look like something like this diagram. Means it will be something like this at this place.
it will be something like this at this place, because we have seen that in the diagram that these were the diagram. So if we align, if we hold the magnetic needle at any place on the earth, so let's say at this place, let's say at this place the magnetic field lines are something like this. So magnetic needle will line along this line, something tangent to this line. If we talk about this place, so magnetic needle will align something like this, and if we talk about this line, the magnetic needle will align something like this. So this is what exactly is this diagram is showing, that the magnetic needle, that how the magnetic needle orient when we take it to the different places. So this is what exactly is the diagram, we can check it out. Now so we have seen that angle delta is the angle of dip. Now if we talk about over here, like we have to check it diagrammatically only. So if we say that this is the earth, we have, so this is the center of the earth, and if we say that, and if you want to find out the angle of, or let's say if you want to find out the horizontal component at any place, let's say if I need to find out the horizontal component is this, the perpendicular to radius at this point P. Now if we change the point, we say that at this point, so this point, the tangent at this point is the horizontal component, and similarly we have the horizontal component, the direction of horizontal component is something like this. Now this, if you are confused that this is something like this is something like the orientation of the magnetic needle, so it is not exactly the thing. Let's look at this in the diagram only. So if we check it out in the diagram, so we have seen that the tangent to the earth surface is the direction of horizontal component. So if we check it out that if we check it out at this point, let's say at this point, now the tangent at the earth surface is something like this. But if we check it out the direction of magnetic field, the magnetic field is something like this, tangent at this point. So therefore what we can say that this angle is denotes as delta. Now let's look at another place. So if we look at this place, so we can see that the horizontal component of the direction of horizontal component of the magnetic field is this. But if you look at the alignment of the magnetic needle, so the magnetic needle will be something like this, tangent to this. So therefore what we can say that this is the angle delta. So therefore we have different angle of declination, or sorry, therefore we have different angle of dip at different places. Now if we talk about the equator, let's say over here, so at the equator we can see that the direction of horizontal component of magnetic field is something like this, means horizontal direction is something like this, tangent to this place. And also if we check it out at this point, so therefore the alignment is also something like this. So therefore there are two parallel lines which is something like this, so we can say that delta is coming out to be 0. But similarly if we check out at the poles, the magnetic needle becomes something like this, become something like this, because at the magnetic poles the magnetic lines are coming something like this. So at the poles it becomes something like this, and the horizontal component is this, so therefore they are perpendicular. So we can make a statement that at equator only BH component exists and BV is 0, that is the vertical component. And also we can say that at poles only BV component, that is the vertical component, exists. There is no horizontal component. So now let's proceed. Elements, horizontal component of magnetic field. We have seen that what is the horizontal component magnetic field. Also according to the definition, like the total intensity, we have seen in the diagram two planes we have seen, in which the total intensity of the earth magnetic field does not lie in any of the horizontal plane. So instead it lies along the direction at an angle delta to the horizontal. So therefore the component of the earth magnetic field along the horizontal at an angle delta is called the horizontal component of earth magnetic field. So similarly vertical component also, so therefore we can write BH is equals to B cos delta. We have seen that this was the diagram with us, that this was the magnetic field B, and this was the BH. This was BH, and also this was BV. So, and this was angle delta. So therefore, if we take out the components, BH will comes out to be B cos delta, and similarly BV will comes out to be B sin delta. And if we take out the resultants, what we are going to get, B is equals to BH square plus BV square. So this is what exactly is the thing, and we have seen diagrammatically also that what exactly is the angle of dip. Now coming towards the tangent law, if we look at the tangent law, if the magnetic needle is suspended in the region where the two magnetic fields are perpendicular to each other, the magnetic needle will align itself along the direction of resultant field of the two fields at an angle theta such that the tangent of the angle is the ratio between the two fields. Now look at this diagrammatically, that if this is the magnetic needle we have, and if we say that this is the magnetic field 1 and other magnetic field that is the perpendicular, what we are going to see that the magnetic needle will align at an angle theta to any of the field, and or it will align in the direction of resultant magnetic field, and therefore what we are going to get, tan theta will come out to be B2 divided by B1. So this is the relation you have to remember, that tan theta is the, and this is called the tangent law. Tan theta is equals to B2 by B1. Now let's proceed towards the example. Now the concept of there is a question like choose the correct statement at the neutral point. So the concept of neutral point we are going to study in the question only. So what is a neutral point? We can say neutral point is that point where the magnetic field because of the needle cancels the magnetic field because of the earth. So if we check out the options, so this according to the option, the magnetic field of the magnet is 0, no. The earth magnetic field is 0, that point is no. The earth magnetic field and the magnet's magnetic field are equal, no. So if we look at the fourth option, if it is there, earth magnetic field and the magnet's magnetic field, this is field, are equal and opposite. So if these are equal and opposite, therefore these will going to cancel each other, and if these will going to cancel each other, then only we will have those points where the resultant magnetic field will comes out to be 0, and we call those points as the neutral point. Now let's proceed towards the next example. So in the next example, the earth magnetic field always have a vertical component except at, okay, so they are talking about the vertical component that has a vertical component except at, means we have studied in the this we have studied that this is the, if this is the earth, so we have studied that the horizontal component is this, and again this we have studied that if these are the lines, magnetic field lines, at this point of the equator, these two lines are parallel to each other. So therefore you only have the horizontal component, and BV is equals to 0, that means the vertical component, this is non-zero. So therefore this is only at the magnetic equator. And one more thing, that declination is 0 at the equator because the lines are parallel, and at these points where BH is 0 and you only have the BV component, delta is equals to 90 degree. This we have seen.
Hopefully guys, you have understood the explanation part, and moreover you must have enjoyed doing questions. I'll come up with the new part, that is where I'll categorize certain materials, and for that stay tuned.